Thanks. Yeah, thanks everybody for joining. We have another session of the YouTube live, and Rana, if you can throw up the introductory slide. We have Abhishek here speaking with us today, and we're going to go through some EMAG. So we've been doing this entire story surrounded around the e-bike, and I've done a lot of the structural simulation, a lot of the structural components. Last time we had a little bit of plastic design, plastic mold prediction. And now we're going to get some I think some really fun stuff. Yeah, structures is fun, but to me, it's kind of like, it's what I do every day. So it's getting a little humdrum. So he's going to start talking about some EMAG, and in particular, where to place a GPS tracker, which is kind of interesting to me right now because I'm in the market right now. I do a lot of mountain biking, and I'm actually looking at purchasing a new GPS tracker. So the timing is kind of fun with this. So with that, let's get rolling. Let's get into some EMAG and show us what it's all about.
Sure.
Yeah.
So I guess I can start with the workflow, right?
Yeah.
So everybody must be familiar with the e-bike model, right? I'm sure you might have seen the e-bike, how it looks. I'll just give you a look at this. Yep. Yeah, this is the model, right? So this is a SolidWorks model, and many of you might be aware how to actually save a SolidWorks model onto the 3D Experience platform, and then basically get it on the platform, and then through different apps. So what I was showing you before, this is my dashboard. It's called the 3D Experience 3D dashboard. And over here, I have this compass logo where I can go through many apps. So one of these apps is CST Studio. For that, you have to have a role called the electromagnetics engineer role. So this is the role that we'll be looking at. And within this role, you see there are two apps. There's either CST Studio Suite Connected and CST Studio Suite Cloud Connected. The logos are the same, the names are almost the same. So you might feel that it's what's the difference, but there's not much of a difference actually. Both of these apps can be launched and used for performing simulations. The basic stuff happens in both of them. The only difference is in some technicality, that is this gets launched on your machine, whereas this one gets launched in your browser. So that's the difference.
Interesting.
Today
So,
for this,
so you're in a browser right now, right? So that's what the
yes,
dashboard is. It's like you're
exactly.
in Google Chrome or whatever, and you're just kind of using this as your launching place. Is there technical differences in the capabilities between whether you launch this in the browser versus a thick client or whatever?
Yes, actually, there are limitations for the browser version right now, because this is relatively quite new. I mean, I think it came out last year or so,
Mhm.
and that is why not all of the things that you can do on the machine, that the standalone version can be done on the browser version.
Yeah,
But
that makes
it's picking up. It's I think probably in a year or two you will be able to have all the features in the
wow,
browser version. Yeah.
cool.
So so how you launch this CST is by clicking on this app, and what you see is this window that pops up. So I'll just show you a new window. This is how you will see. This is the CST window with your recent files that you have worked on previously. You'll see over here, and it will also show you whether you want to load something from the 3D experience. Like for example, our SolidWorks model, we
Yeah.
want to load it from the 3D experience platform, and it will also show you the different modules over here. Um, so without wasting any time, I'll just show you how to load the e-bike into CST. So you click on this logo, and there's the first option. There's load 3D experience content. And when you click this, it starts. It loads um, the interface of the platform where you can search all the different things that are saved to your collaborative space.
Mhm. And so
So just
that's CST we saw right there, the like CST standalone or something.
yeah, yeah. This is this is not the browser version. This is the version that you can basically open on your machine. You need to install
Okay.
it.
Yeah. Nice. Yeah, when you went to that other screen, is very familiar. It almost looked like I thought you were switching over to your PowerPoint slide deck or something, but that's just like the layout looked very familiar like that. So that's pretty awesome that they're starting to integrate some visuals of the other tools that we've all been using for years, SolidWorks and Microsoft products, and just kind of bringing it all together and making things very very familiar to us. So
Yeah.
yeah, and this is everybody, this is a live demo. We only do live demos here. We really try to not do any videos. So he's accessing some server. I don't even know where your server. So the two of us are in a 12-hour time difference, and when I do demos, I access servers in Europe quite often, and I know you guys access servers over here quite often. So it's all very exciting that's the beauty of the cloud, right? Anywhere, anytime, any place. For real, you can really be anywhere with the connection to the internet, whether you're hotspotting off your cell phone or whatever. I mean, it's just so incredible. Sorry.
Right.
Okay, keep going.
Yeah, even this one is the European server, by the way. So the EMEA demo is actually, it's located in Europe. All this data gets saved over there, centralized, and we all access this, the data on this particular server, and it's not pretty bad actually. We can very quickly download data. So yeah, so what I'm doing right now is I'm searching for my data. So I've entered a keyword called SparkWorks, but what I see is that there are multiple files. You see, so I don't know which one of them is mine, because maybe a lot of people are working on the same files. So I go to this button called 6W tags. W meaning what, where, who, all those kind of things. And here I want to see data that I have uploaded. So within this, I can see the persons, and here's my name, Abhishek. So I'll just click on this, and it will now show me only, yeah. So this is the only file that I've uploaded with the same name, SparkWorks e-bike.
Yeah.
So what I do is I select this. I close this. Yeah. I select this, and then I say okay. And when I say okay, it will start, loading the data onto my system. So since I've already done that, I'll just click cancel right now, and I'll show you the bike model that gets loaded. And so this is how it looks.
So you launch it through the 3D experience, and then it would put it in CST here like this.
Exactly. Yes.
Okay, cool. I mean, again, like the database, that's the thing that we just get. We're simulation people, but we get all this data management, not for free, but it just comes along with the package, and it's so great. I mean, I talked about it in one of my previous sessions, just data management nightmare that I am. So this is great. Right.
Yeah, because even a lot of people may be working on the same data. So
Yeah.
you have the option to lock your file, so that people who work on your file cannot actually modify it when you're working on it. You can keep it unlocked so that multiple people can work and then save different versions of the same file. So it's really fantastic.
Mm.
Yeah. So coming to this workflow now, you can see the e-bike loaded over here, and I'll just give you a brief overview of how CST looks. What are these options that you see right now? I am sure you're seeing many of these options, and you're kind of thinking what is really required for us. So I'll quickly show you. This is called the navigation tree on the left hand side that you can see. This shows us all the different objects that are in the simulation area. So this area, this 3D view that we see, we can call it the simulation area or the 3D view. And out of the first option that is called components, it is basically all the CAD that exists over here. So here you can see the Sparkworks bike, e-bike. This is the, it's a product, and within that there are multiple, sub products, or you can say parts, that come from SolidWorks. And when you select each of these parts, only those parts get highlighted and the remaining goes, it gets transparent. So it tells you basically what how many parts are there. If I go within these, you will see that, again there are several parts, like the brake shifter, the brake cable. So many of these things, I think, all those who are familiar with the bike model, you already know this model, very
Yeah.
nicely. Apart from that, yeah, so there are other folders like materials, groups. Currently, this e-bike has only materials that came from SolidWorks. So these materials are not really of any use to us, because we need materials which have electromagnetic properties. So basically, a thing that is a metal needs to be defined as a metal in CST. But before doing that, let us first, load all the different CAD that we want to work on. So this is just the e-bike, but we need other things also. For example, since this entire demonstration is about antenna placement, we also need an antenna module that will get fixed on this e-bike. So and also we also need a human model. So let's go back to the same 3D experience logo, and again let's search for the human rider that will go on top of this bike. So again, I click on this and it starts loading all the different content that I have. And then
So
I search. Yeah.
the material that you mentioned, so
Yes.
it's a material that's specific to CST. So can you store those characteristics in the 3D experience material
Yes,
property?
you have. You
Oh,
can. Sure. There is a
okay.
way to store that. There is a material library in 3D Experience platform where you can save all the properties that are get defined in CST. So
Okay.
this for this model actually it directly came from SolidWorks.
Oh,
So
oh,
we would
gotcha.
not really, go to the platform and define those material properties. We could have done that, but nevertheless, we can do that in CST also.
Cool.
So yeah, so this is a human rider that I was talking to you about. It shows me only one file with the same name. So again, I click on OK, and then it loads the human rider. So I've already done that. So I'll just show you how it looks. This is how the human rider looks,
That
and
looks like
yeah,
Ronnet dancing or something.
sorry.
That looks like Ronnet dancing. I'm not sure if that's Ryder or what.
Yeah, so that's actually, we used a platform tool called Human Design, and that gives us a variety of human models, and you can actually pose it in the way you want to. So for this demonstration, I have not actually covered those steps, but it's really a fantastic tool. You can pose it in any way. There are constraints, like your elbow would move only up to your particular angle. It won't go the
Mhm.
other way around. So all
Yeah.
those constraints are already fixed in that app. So it's a wonderful tool.
Cool.
And yeah, using this tool, I was able to pose this model and then download it now. So, but as you can see, it's not placed on the bike. We want it to be exactly sitting on the bike. So very easily we can actually, translate this model to the place where we want. So I have already the XYZ coordinates of this human model. So if I go to the navigation tree, I select the e-bike human rider, right click and click on transform. Transform will give me a variety of options, whether I want to translate, scale, rotate, or mirror. Right now, I just want to translate it. So I'll enter the XYZ coordinates over here. I can also like just drag it, this way. This also does the job very easily. but it won't be accurate. If I want really to be it to be placed exactly on the seat, I need to enter those values over here. So I have those values with me. So I'll just quickly enter them.
While you put those in, just a quick comment to this, the people viewing. If you have questions, please be sure to put the questions in the chat. Let us know if you have questions. We'll try to answer them as we go, as they fit. Or if we don't have time during the presentation, we'll get to them at the end. And again, always, like the YouTubers say, like and subscribe. Be sure you're hitting that like button if you like this. Subscribe so that you know when our next sessions are coming out. And go back, give us some feedback on these videos. We really want to hear from you guys. This is for you. A little bit for me today because I don't know anything about EMAG. But again, these presentations are for you folks. So let us know how we're doing. Let us know if there's other content you want to see that we're not covering. If you want more details of something, but yeah, please send in your questions as we go through the presentation today. All right, sorry. Is your guy positioned?
Yes.
Keep going.
Yes, so I have positioned the human being, and now what it says is that there is a shape intersection. So it's basically just notifying me that there's an intersection. What do I want to do? And it's highlighting the two shapes that are intersecting. So currently there's an intersection over here. If we zoom, there is something touching it. I think it's over here. So the cloth, that is the pant, is a little bit interfering with this part. It's I think it's called the I'm not sure what it's called. It's some part of the bike, but this is where the chain goes, right? This is where the chain goes of the
Yeah,
bike. Since from the EMAG point of view, it doesn't matter. Even if there is a slight intersection, it doesn't matter. Maybe for structures or fluid workflows, it may matter. But from an EMAG point of view, it really doesn't matter because this one object is metal, the other object is basically human tissue. A slight intersection will do. So what I'll do is I'll just select apply to all intersections and I'll say none. So nothing will happen. If I say something else like insert the highlighted shape or trim the highlighted shape, then accordingly that CAD will get modified. Since I don't want that, I'll just say none and OK. And now you can see the human placed exactly where it is supposed to be. So yeah, so we have one part, we can say one part of CAD, that is 50% of our CAD definition is done. The other 50% is the communication model, the antenna module. So what I now do is that I create a new file. I go here, new and recent, and I click under 3D simulation on high frequency because we are all working on high frequency simulation, by the way. There's low frequency, there's high frequency in EMAG. How do you like define what is high and what is low if you're thinking about that?
Yeah, that's my
Then
question. Thanks.
okay, I thought you would ask that. Yeah.
Yeah.
So high frequency is basically anything that is in the terms of like hundreds of megahertz. So I'm sure you know this unit called hertz, right? Number of cycles per second.
Yeah.
And megahertz is like 10 raised to 6 uh, hertz. So most things, like for example your radio, are most of our radios are like 98.7 megahertz, like almost in the range of hundreds of megahertz. Your GPS antenna, it works at 1500 megahertz. So it's definitely high frequency. Anything that is low frequency would be in the range of kilohertz. So just like 10 raised to 3 hertz. Most applications like motors
Yeah.
or or some sensors which don't have anything to do with data transfer, but just like electrical stuff, that will be low frequency stuff.
So these megahertz are the different kind of megahertz from when I did the impact study when we were crashing the bicycle. That's a completely
Oh yeah,
spelled very differently,
definitely.
too, right? Yeah. Okay. Sorry.
Yes, yes. So yeah, so I now created a new file, a new high frequency simulation file. And what I do here is again, I go to the 3D experience logo and I load, another model, that is the communication module. This is again a file that comes from SolidWorks. So just like the bike, we had saved another file called the communication module, completely developed in SolidWorks, and that was saved to the platform. So now what I do is I'm just looking for this file. I'm searching for the file on the platform. Uh, this sometimes takes a minute to load.
So while that's loading, we have a question from the audience. I know for structures, we have some examples and things like that that are accessible. What about the EMAG stuff? You know, obviously we're supplying the bike models, but does the software come with any tutorials or examples or anything like that?
Yeah. There are many courses on the EduSpace, the official tutorial site, where you can actually opt for these courses, and it gives you a very hands-on experience where you can download models, execute the simulations, and then verify your results with the results mentioned in the tutorials.
Okay.
So
Yeah, because I
it's
know
you can
SolidWorks comes with, like, you can go through the help and there's all sorts of awesome examples. Is that kind of similar setup then, I guess?
Yes, definitely.
Cool.
It's all from an EMAC point of view. There are several
Yep.
modules in CST. This is just the high frequency module that we are actually going through right now. There are multiple modules even the low frequency. There are sub modules. There is EMI, EMC. Each module has a curated list of examples. You can, go through those examples, and at the end of the day, you'll be pretty much confident on working on EMAG workflows.
Nice.
I can guarantee that. Yeah. So yeah, this is how the communication module looks. I was trying to load it actually from the platform, but I think I need to, reload CST. But luckily, I have loaded the communication module already in CST. This is how it looks. It's I've hidden the top screen. This is basically, you have those devices which have the display as well as the antennas. It's like a phone basically that goes on your handlebar. And what you can see over here is there are two antennas within it. So this antenna that you can see, the bigger one, this is the GPS antenna. This is the main antenna. And the second one over here is the Bluetooth antenna. So this device basically has two antennas. So what we do now is that we have all of our CAD already imported from SolidWorks into CST. The next step is material definition. So let's first go to the e-bike with the human, and I'll quickly show you how to define materials. So I right click on this e-bike over here in the navigation tree, and I say assign material and color. And over here, since we know that the bike is mostly metal, mostly steel, so I'll go over here and I'll say load from material library. This will show me the list of materials that are already in CST. They are inbuilt. So there's a huge list of materials, like there's air, aluminum, all kinds of materials, fully defined. With different things, like even the thermal properties, the EMAC properties are completely defined.
And that
All you have
comes
to do
with
is,
CST?
sorry.
That comes with CST?
Yes, that comes with CST, and there is another additional module of an extensive list of more materials. You can also download that from the DS website. So yes, this is the material that we need. It's called steel. I'll just load this material, and then I'll say override material color, and I say okay. So what this does is that it does not take the color of the material steel, but it takes its original color. If I had not checked that box, everything would turn fully gray, which is very bad for visualization. So right now, what you can see is that the entire bike has become steel. But we all know that there are some parts that are not steel. For example, the tires, or the brake handles, the grip of the handlebar. So what we can do is we can just go to the navigation tree and look for those parts, and then right click on them. We can select by keeping control pressed, and then we can select those parts. It will keep on highlighting those parts, and what we can then do is right click and then assign material. And just a second, I'll just even select the uh, the tires.
I think there's some other software that could use this sort of selection visualization. That's awesome. Like wireframe outlines. That's great. I love it.
Yeah, I mean, right now I was not able to recollect where those parts are in within which subfolder.
Yeah,
So I
yeah,
just clicked on it, and it showed me where exactly it is.
that's awesome.
So yeah, I just selected over here, assign material, and again I go back to the list, and this time I look for a different material, which is rubber. I mean, we can go in a lot of detail in this, but for this demonstration, I'm just selecting two materials, that is steel and rubber.
Cool.
So I search for it and see, I see over here rubber. I load the material and I say okay. So this material also has got defined now. Similarly, for the human being also, we have a separate material. It's called the muscle tissue fat average. So before that, this model actually has a lot of parts. So when I clicked on this module, as you can see, there are multiple parts here. And whenever I take my cursor, it shows me which part is selected. It highlights that in red without even
Whoa.
clicking them. And so what I came to know that it's not really required that so many parts be there. This is like the eyeball, the jaws, the tongue. I don't really want that much detail. So what I'll do is I'll just keep the base module of the human being. The remaining things I'll just select and delete.
So those are probably in there for like somebody doing a cell phone or a Bluetooth headset or something, I guess, right?
Yeah, I mean, if you want like detailed analysis of
Yeah.
how it affects the teeth, how it affects the eyes, then that also you can see. So that's a very good feature. So again, I just assign the material. I go back to the material library and I search for my material. That's muscle. You'll see all kinds of materials over here. You'll see blood. You will see tissue, everything.
Um,
But right now, since everything is just one model, I'll just take a muscle fat average, and I want the color of that material. So now, see, the material has been defined. So we are done for the e-bike. Similarly, we can also define materials for the communication module. As you know, some parts of an antenna are metallic, whereas some parts are dielectric. So we need to define exactly which parts are what. For example, I'll not show all the materials, but I'll show you just one of these things. So for example, this is called the dielectric. This is basically it's like an insulation on which there is a patch. So this is the patch does the job of radiating electromagnetic waves out of it, but it needs to be placed on something that is an insulation, and below that you'll see another metallic object called the ground plane. So then, as you know, like basic electric, there needs to be two potentials, plus and minus. Similarly, we have the radiating element and the ground plane. So between these two things, we have the electric field that gets converted into an electromagnetic field and it starts radiating. So again, we assign a material. This time, my material is not in the library. So what I can do is I can just create a new material and I can give it my own name, just as I want to. So I call it ceramic, and the electromagnetic feature over here is called epsilon. Epsilon is basically it is relative permittivity. This is something that defines how your electric field will be stored within that material.
Yeah.
So I know that for epsilon, for ceramic, the epsilon value is 66. I got it from a data sheet. Okay, so I just click OK, and this material gets defined. Likewise, I can even define other materials. And once I'm done, so I can even change the color if I want to. If I think that this is a very dull color, gray, I can go here and select blue, and select, maybe I can call it plastic, this material. And the epsilon value for plastic is 1.2. So I define this, and this becomes blue. So that's how easy it is to change the materials, the electromagnetic properties, as well as the visualization colors in CST. Once we have defined all the materials, the next step is port definition. So we wish to create an area within this antenna where the excitation will be occurring. So basically, if it was a physical antenna, where do you connect the wires to the antenna so that it gets charged up and it starts radiating? So for that, there is a tab called simulation tab. When you click on it, you'll see a option called a discrete port, a waveguide port. There are different kinds of ports. So what we'll do is we'll create a discrete port. So the object where the port gets created, for example, if I look in this tree, I need to look for the coax. Coax is the coaxial connector. That is where we want to define. So it looks something like this. Generally, it has multiple conductors and a dielectric in between, but this is like a simplified version of the coax.
Mhm.
So what we do is we select the edge. For that, I'll type E. I'll hit E. It gives me an option to select the edge. Okay, and then I can select the ground plane. So if I go to ground, this is the ground plane, and I select, let's say, F, and I click on discrete port. So I'm basically selecting two areas where the discrete port will be created between those areas.
Mhm.
So this is how the port looks like. Now, ideally, I would want the port to be completely, circular around it, because the electric field will obviously be, flowing through the entire port, not just through half of the conductor.
Right. Right.
But since SolidWorks, while importing the data, this cylinder got divided into two parts, and that is the reason when I select the edge, it selected only half of the edge. So uh, either I could fuse those two halves in SolidWorks, or I could simply select the coax once again, and I could create another cylinder over here. So if I say modeling, pick circle center, I select the center, and then I create a cylinder over here. So there are modeling capabilities in CST also. You don't need to go back to SolidWorks for very, very small things. You can do those things in CST also.
That's good to know, because sometimes I know this is not SolidWorks. Obviously, this is CST. Even if you try to make that, it may have originally been one surface in SolidWorks. So sometimes when you move to even 3D Experience or this, that you have to have some way to make that back into one, because it just automatically splits it in the translation. So that's cool to see that you have this capability. We have about, I've been asking too many questions, so I've really kind of pinned back my questions. We have about 10 minutes or so left. So we'll keep running through here. Again, folks that are watching, please remember to like and subscribe so you get the latest and greatest updates. Okay, Abhishek, let's go.
Yeah. So now that I've created this cylinder, now I can simply, I can select the two faces of this, and the two edges of this, one top edge, one bottom edge. So now I have two complete edges. And now I click on discrete port. And the entire port, as you can see, is, it's throughout the circumference. This is what I
Yeah.
was trying to achieve.
Cool.
So now that I've created the port, similarly we can create another port, but I've already done that. So I'll quickly show you the next step, that is creating the assembly project. So what we wish to do is that we have created these two CST files. One is the e-bike with the human. The second one is the communication model. Okay, and now the next step is to place this on the e-bike. So we need to create those points where it's going to be placed. So I select this particular point and I call it, I create an anchor point. So when I click on this particular option, I say align WCS. The WCS is basically the working coordinate system. And I say store it as an anchor point. The same thing I do even over here. Uh, I can either select a point over here where I want the communication model to be placed, or I can even use the XYZ coordinates and directly define the coordinates through that option. So yeah, so I need to pick points from coordinates, and here I define those points, and then I do the same thing. I create an anchor point. So both of these files have the anchor points. Then what we do is that we create a new file. Okay, we go to new, and this time we say an assembly project. So we want to assemble two different blocks together. So now we select those blocks. So here you say import 3D block. So both of these files are now locally saved. Even though we got it from the platform, we did save it locally. So let's see those files. So the first one is the e-bike with the human. So I click open, and that gets loaded in this new project. Yeah. And the next block that I import is the communication module. So this also gets loaded over here. You can see this yellowish black spot. That's basically the anchor point that we just created.
Mhm.
This is the areas where we want, the two blocks to get connected. So I go to assembly modeling, I select the communication module, and I see it, it's somewhere completely different. I say snap anchor points so that I can, connect these anchor points. So I select this one, and then I select this one, and the module quickly just snaps back over here. And now I can change the orientation by just, clicking tab. It will keep on rotating. And yeah, this is the orientation that I want. So I click enter. So now this gets fixed over here. So we have the antenna placed on the e-bike. The next step is to define the simulation. I could define, everything in just one simulation. Like I don't need to create a separate block for the e-bike and a separate block for the communication module. I could just define everything in single simulation. But what would happen is that the mesh size would be extremely large, like in billions of mesh cells, because 1.5 gigahertz is a very high frequency. So solving billions of mesh cells will take a long time. But if you have GPUs, yeah, if you have GPUs, then you can even solve them like within a day or two. But since we don't want to do that, we want to solve this very quickly. What we did is that we created two different blocks, and now we create a simulation project called the hybrid solver task. So what this does is that it basically solves very finely only the communication module. It records the waves that come out of it, and it only takes those waves and excites the entire e-bike, as opposed to solving the entire e-bike. It is only solving the small portion. So I'll show you how that looks. So it's now asking me define the simulation project for platform. So platform is basically the structure that wants to be the larger structure that we want to select. So it's the e-bike. We select the e-bike, we click 3D model, and we say create simulation project. And here we define the solver. So we have a list of solvers that we can select. There's integral, there's transient, frequency domain, TLM, that is transmission line matrix, and asymptotic. Asymptotic is a solver that is basically the fastest solver because it uses the shooting and bouncing technique of simulation. So it's quite fast. We select this and we click OK. Now it asks us to select the source. So I select the source. Again, I click on 3D model because I want an actual model. And then I click on create simulation project and I select the solver. This time I select TLM solver. TLM solver is it's a very good solver that very finely uh, solves your simulation. It uses basically Maxwell's equations. All of these EMAG tools, they use Maxwell's equations to actually solve at each of those points. So we select that, and once we have defined the source and the platform, it still asks us, do you have another source? So in our case, we have only one source, that is the communication module. So we then click OK. And as soon as we do that, we see this hybrid solver task get created over here. So when we click on this, it shows us the task parameter list over here, and it asks us a few things like what are the different frequency points or frequency samples. So in our case, since we have only two antennas, that is the GPS antenna and the Bluetooth antenna, we enter only those particular values. So I can enter the value of frequency for the GPS, that is 1.575 gigahertz, whereas for the Bluetooth antenna, it's 2.45 gigahertz. That's the standard band in which all Bluetooths transmit and receive. And the number of frequency samples, only two. So I want to see only the fields at these two frequencies. And once I'm done with that, this is a bi-directional solver. So what it does is that it excites this particular box that you see over here, right? And the smaller box gets excited and it records the field due to this box. Then it goes to the e-bike simulation model. It excites the entire field with that particular fields recorded from the small box. Then whatever reflections come from that from the bike, let's say the field hits this metal object over here and then reflects back some field uh, towards the communication module, it records that too. So now this goes back and forth multiple times, and then it checks does an iterative solve. So it solves multiple times. It sees the reflections because of this. Again, it adds those reflections and simulates the source. Again, it does that until and unless between two iterations there is an error of 1% or less than that. Then it stops solving, and that is when we get the right results. So what I need to do is just need to right click and say update, and once I click that, it will take about like 1 or 2 hours depending on your configuration, of course. And then what you will see is the results. So how do you see the results? The most important thing is the 1D results, the S parameters. S parameters are basically the return loss at that particular frequency. So firstly, we'll see the return loss at the GPS frequency. So I'll just move this axis marker, which will show me the return loss at my GPS frequency. So it's about minus 21 dB, which is pretty good actually. We want a return loss of less than minus 10 dB, and what we are getting is minus 21 dB. So that's pretty good. So there is no field that is coming back from the those cables that you connect to your antenna. Most of it is going to the antenna and then getting radiated. That's exactly what we want. Similarly, at the Bluetooth frequency, uh, the again the return loss is about minus 22 dB, which is again good. It's minus 21.96 as mentioned over here. So both of our antennas are having very little return loss. So that is the first indicator that our antennas are functioning properly. The second indicator would be looking at their radiation pattern. So you can see over here, there is this reddish orange ball. It shows us basically in all the directions how does the field, how does the gain basically, you know, uh, act. So you can see this color bar over here. It says red being 2.46, and as it goes down, it keeps on reducing. So it basically tells us that in this direction, in the topmost direction, we see the most amount of gain, the antenna gain. I can change this directivity to gain, and it will show me the value. Okay, and this is how the gain looks. Likewise, I can even see uh, the gain for the second antenna, that is the Bluetooth antenna. And over here, you can see the pattern is a little bit different. It's not,
Yeah.
circular, it's not spherical. But that's okay. The GPS antenna, as you know, it communicates with the satellite, which is like tens of thousands of kilometers up in the sky. Uh, the Bluetooth antenna, on the other hand, will probably just communicate with the phone that is in your pocket. It's quite close. So even if the radiation pattern is not that good, it's okay because there will be the phone is quite close, so there will be multiple reflections. You're on the floor, and then it will hit your. There will be it will receive on your phone's antenna. So this is another way of seeing how your antenna is performing. The last but not least, there is another um, way of seeing this is the E field. So if you look at the E field, just a second.
So I know we're right. We're over just a few minutes, but this is this is pretty good stuff. So I'm gonna let you keep going here. But for those that are subscribed, don't leave. We're right here at the end, the good stuff. So we'll leave just a couple minutes for some questions. But yeah, this is fantastic. So keep going. We'll go for like another couple minutes here. Yeah, show us this.
Yeah, this is almost done. So this is the last result. This is the result that tells us how the electric field is radiating. So as we can see, it animates the entire field according to phase. And at this particular cut section, we are able to see that from this antenna how the radiation occurs. So we can see that in the lower portion, there's almost no radiation. That's probably
Yeah.
because there's a lot of metal. Like for example, this handlebar is metal, so it's blocking all the radiation in the lower part. Whereas in the top section, the communication module itself is made of plastic, and plastic does not block any radiation. So it's
Yeah.
very easily. I mean, it may change the amount with which it is radiating, but not much as metal. So this is actually a very good way of seeing whether our antenna's radiation is being blocked in a particular direction or not.
Mhm.
And in our case, it's from all ways, like the return loss, the antenna gain, and the E field. All three ways we are seeing that the antenna is performing well.
Yeah.
If it was not performing well, then we would have to do some design change. We would have to change the position of the antenna, the orientation of the antenna. A lot of things that we could do. Um, you know, those are very much easily possible in SolidWorks. So yeah, this is it from me. I guess I
Cool.
can take any questions if there
Yeah.
are any questions. Go
Yeah.
ahead.
Thanks, man. Again, everybody, thanks for watching. Like to go through any kind of simulation in 30 to 45 minutes is always a huge task. So thanks for hanging in there for a few more minutes, and especially EMAG. I mean, man, everything we have now, everything is like Bluetooth this, Bluetooth that, and with antennas and GPS. And so This is such an important topic. And, the concept of this channel is to give everybody an idea of the different capabilities that we have inside the DS portfolio and the platform itself. And obviously we can come back and do some deep dives, but again, these sessions are just kind of high level. So thank you so much, Abhishek, for wonderful presentation. I'm going to go back and watch this again and probably hound you, because this is really cool, interesting stuff. So the next session we have is how to keep the rider and battery cool. So we're going to do some cooling stuff in the next session. So, I encourage you to, again, like and subscribe so that when these sessions, you get that notification when this session's coming up. And come back and figure out, how to keep the battery and the rider cool. So thanks, everyone. Thank you so much.